Chapter 9, Conducting Experiments. You thought you were done talking about experiments, but not yet. Disclaimer. Let's talk about learning objectives. One of the most fun things that we can talk about in experimental research is the manipulated independent variable and what this means. Also, we're going to break down and exemplify different types of dependent variables that we can measure. There are some qualities of dependent variables that we want to go over, such as the relative sensitivity of the dependent variable, as well as floor and ceiling effects. We'll talk a little bit about how all the expectations of the participant as well as the experimenter can influence the results of an experiment. And finally, we'll explain a little bit about pilot studies and manipulation checks. I mentioned in Chapter 8 slides that there's a difference between probability versus non-probability sampling. This is an important consideration in terms of how we're getting our participants and to explain to readers right out of the gate whether it makes a difference on the overall design and the interpretability of the results. I want to reiterate what I said in the previous slides, which is to say that most of the time, increasing our sample size increases the chance that we are going to get a statistically significant result. For the vast majority of studies that you're going to run into, this is probably going to be true. The only time that this is not going to be true is in these huge epidemiological studies where they have like 50,000 participants or something like that. And that's not something that we're going to be seeing very much of in social science research. So we're not going to worry about that for the purposes of this class. This part of the chapter, I think, is one of the most interesting things to talk about, which is manipulating the independent variable. Social psychology has some of the most interesting manipulations out there because it really says some interesting things about people. In the textbook, it talks about the Goldstein study where one group of people staying at a hotel was asked to help save the environment by reusing their towels. In that particular condition, only about 35% of the guests actually did that. But when they invoked a social norm by stating instead, "Please join your fellow guests in helping us save the environment," or something to that effect, this time 44% of the guests actually did what was asked of them. So what this suggests is that manipulating the independent variable to include a social norm actually influences people's behavior. This is an example of a straightforward manipulation. We're looking to groups of people and the manipulation is rather obvious. Compare this with a staged manipulation. I think these are by far the most fun because what we're trying to do is purposely create either an emotional state or some type of confusion or something to that effect so that we can try to make some guesses about what people might do in these sort of vague situations and then might maybe make some predictions about their behavior. In these instances, we often use confederates, and this is a psychological term for people who are basically actors in the experimental scene. In the book for this class, it uses a couple of examples, and I strongly encourage you to look at some YouTube videos for the Asch conformity experiments. In these scenarios, a person was in a room with several other people who were asked to answer a question that had a pretty obvious correct answer, but all of the people in the room except for the participant were confederates or actors. And when those people all unanimously and continually gave the wrong answers over and over again, even when the obvious correct answer was still there, the participant in the study would actually go along with the wrong answers because of their tendency to conform rather than be just disagreeable. So make sure you read about this in your textbook on pages 170 and 171. It's super interesting stuff. Here's an example of something that you might see in one of those conformity experiments I was just referring to. If you look at all three of these lines on the right, you might look at the standard line on the left and ask a person which one of the comparison lines is closest to the standard line. And obviously line number 2 is the longest of the three comparison lines. But in a room full of actors or confederates who are pretending that line number 3 was the closest, and everyone in the room was confidently saying number 3 was the closest, you might find yourself agreeing with them rather than being disagreeable. Everybody likes to say that they wouldn't disagree with the group, but when they studied this over and over again, participants more often than not went along with the group, even when they knew that the answer was wrong. Super interesting stuff. If we're going to do manipulations in studies, we want to do something that has an extremely strong relationship to the desired outcome. In some instances, the more ridiculous this relationship is, the better. The more outrageous, the better. There's two things you should be thinking about, however. The more ridiculous the manipulation is, also the more likely it is to be unrealistic or not applicable to the real world. Also, we want to make sure that whatever manipulations we're using, it doesn't border on something that's unethical or unhumane or might even cause harm to somebody or might trigger somebody. In the past, psychological studies like the Ash experiment sometimes left people feeling a little bit traumatized by their experiences, and so we have to be really careful not to do those sorts of things anymore. Other considerations are using manipulations. That can be really time-consuming and costly because we essentially have to hire either actors or graduate students to be Confederates in experiments, and then we also have to spend a lot of time and energy developing apparatus or stimulus, other things to create these unusual situations. So most of the time, the straightforward manipulations are a little bit better bang for the buck and easier to manage, but aren't always quite as interesting as those other types of manipulations. We've been talking about manipulating independent variables, so let's switch gears here and talk about dependent variables. There are a few common ways that we measure dependent variables, and remember, dependent variables are outcome variables. We're not manipulating a dependent variable. We're looking at an outcome or an effect. Probably the most commonly used method to detect dependent variable changes is through the self-report. This can be people writing things down in a journal or endorsing numbers on a behavior scale or maybe verbally reporting something that they're experiencing. In addition to self-report, researchers can also do direct observation. You might recall from previous slides that I talked about inter-rater reliability and used the example of directly observing aggressive behavior in children. As an experimenter, we would simply be logging different types of behaviors that we might see kids do in a natural environment, or even in an experimental setting, such as when we're controlling how much screen time kids might have playing violent video games, and then measuring the behavioral outcomes by direct observation in that environment. Of course, this is just an example, and there are lots of ways to do something like this. Just as a clarification, sometimes behavioral measure isn't actually a behavior per se, but maybe just measuring a person's choices or their intentions, like what's described in the textbook. When somebody makes you upset, you might have an option to endorse on a piece of paper, yeah, I want this person to eat more hot sauce or something like that. So you're not actually making that person do it, but you're showing a behavioral intent. One of the other ways that we can measure a dependent variable is a physiological measure. And here are some pretty common examples like the galvanic skin response. They often use this in studies of anxiety and reactivity. An EMG is for muscle tension and activation. So sometimes they might use that in a stress study. MRIs and fMRIs are obviously brain scans. But there are lots of other things we can do, like simply measuring heart rate or number of respirations a person might have in a minute and so forth. So don't rule out the possibility of looking at something from a physiological standpoint as a dependent variable. Most of the time when we are looking at social science research like psychology, we are interested in singular dependent variables, and this is probably the easiest way to do things because we're only looking at a singular outcome. If you decide to continue on in psychology, you will undoubtedly have to learn advanced research methods where you will look at even more complex designs where you're looking at multiple outcomes or multiple dependent variables. For example, we said that study participants who showed signs of both a diagnosable eating disorder and a diagnosable form of depression, that they would be more likely to A, express suicidal thinking, B, be psychiatrically hospitalized, and C, develop long-term physical health problems. So you can see that we're looking at 2 different independent variables here and 3 different dependent outcome variables. This is pretty complex stuff, but it can be done with enough care and attention. The complexity lies in the relationships between these variables, and it's useful to know how these variables interact with each other. Also, trying to figure out which outcome might precede one another, this can be pretty complicated as well. So using the same example I just gave, if outcomes were physical health problems and psychiatric hospitalizations, would one lead to the other, or would it be the other way around? Would psychiatric hospitalizations lead to physical health problems, or would physical health problems come before the psychiatric hospitalizations? One of the ways in which researchers can accidentally fail to detect a relationship between an independent variable and a dependent variable is the way that they choose to measure the outcome or dependent variable. Maybe their mistake is it's not sensitive enough to capture the relationship or to capture a difference between groups. So let's think of an example. A while back I watched a video on people who competed in CrossFit competitions. Sometimes people who did not win the competitions but were very high achievers might say something like, I came in 6th place or something like that, so therefore I'm a loser or I'm not very fit or something like that. So the dependent variable in a situation like this is whether they won or maybe placed or didn't win or place. And so if our outcome variable would be whether a person's measure of fitness is if they won it or not, that wouldn't be very sensitive, because people competing in a competition like this are probably more fit than 99.9% of the population. They just weren't good enough to win necessarily. So the main point again is that we don't want a dependent variable that artificially limits what it is that we're trying to measure, like it's too strict of a criteria. And we also don't want a dependent variable that is too broad and captures all kinds of information like noise that's not really relevant, or maybe is not sensitive enough in some way. So what we're shooting for here is sort of like a Goldilocks version of a dependent variable, something that's not too much, not too little, but is just right. One of the worst things that can happen in an experiment is when we give participants an opportunity to think about what's going on and develop expectations about what it is we're measuring or what our hypotheses might be. Participants might try to change their behavior in a way that they think they're doing us a favor and trying to help us confirm our hypothesis if they think they guessed it correctly. But of course, this is not what we really want. So in certain situations, it may be necessary to be deceptive in what it is that we're doing in the experiment, so people have a harder time guessing what those hypotheses are. There are a couple of different ways to do this, and we'll talk about a couple of those here. One is to reduce the number of demand characteristics. In other words, we want to develop the experimental scenario in a way where the participant would walk into that situation and not be able to infer what's going on based off their surroundings or who's around them or any other factors. If we were going to also take this a step further, we would want to make sure that when people are filling out questionnaires, that the questionnaire itself doesn't give a participant enough of an idea of what's going on. So sometimes the information that we're trying to measure in there can be mixed up with other information in there, like filler items. For an example, in a questionnaire that measures attitudes about sexism, obviously people don't always want to admit that they harbor sexist beliefs. But if we wanted to measure sexism, we would not want to make it too obvious. So what we want to do, or what we can do, is develop a sexism questionnaire that contains a variety of questions about other related topics, or maybe even unrelated to sexism entirely, that we're just not going to score at all, but we'll just pick out the sexism questions that we've mixed up in there, and these filler questions will fill in the gaps. So at the end of the day, we will subtract the sexism questions out and score just those, and then this way the participant has a lot more difficulty trying to guess what it is that we're really asking. Along the same lines as participants conforming their behaviors to what they think the experimenter might want, in some instances like treatment studies or medication studies, the simple act of, say, just taking a pill can sometimes convince people that they're getting the treatment, and they dramatically start feeling better even when the medication isn't real. In well-designed medication studies, there is usually a placebo group, or a group that receives a pill that doesn't have any real medication or any other substances in it that would produce an effect. Experimenters will then compare the placebo control group to the actual treatment group and determine whether there is a significant treatment effect that is above and beyond the improvement in the placebo group. So what we're looking at here is sometimes people think that when they're getting a treatment they can start to feel better even when the treatment doesn't in fact do anything. We talked in the last two slides about participant expectations. Now let's talk about experimenter expectations. Obviously the experimenter can inadvertently say or do things in the experiment itself that can telegraph messages to the participants about what's going on in this study and affect outcomes. In medication studies, doctors who know the difference between the medication group and the placebo group might actually and inadvertently treat the two groups differently, and this might affect the outcome, even if it's unintentional. So to help minimize these kinds of expectancy effects, we at least want to employ a single blind experiment where the participant is not aware of whether they're actually receiving an actual treatment or not. But an even better option is the double-blind experiment, so that even the experimenter and the participant both don't know whether the participant is in the treatment group or the control group. Only a study administrator or some other high-level person would know which of the pills were the real pills versus the placebos. Obviously, when we're comparing different types of therapies, such as different forms of counseling interventions, we can't double-blind the therapist because obviously they're going to know what type of therapy they're giving to a participant. So my main point in stating this is that double-blind scenarios might be a best practice, but they're not always possible. Final things to think about. One of my favorite things to try and conceptualize is pilot studies. No, these are not studies on pilots. A pilot study is when you do a trial run with a small number of participants to try and work out any bugs in the methodology. For those of you who are film fans, if you ever saw the film Ocean's 11, you can see that the people who are engaged in the Las Vegas heist are doing practice sessions so that they can work out any bugs that could potentially compromise their operation. That's exactly what a pilot study is for. What we don't want to do is spend a lot of time, resources, and money on doing a huge study that ends up having some pretty big errors in the methodology that might make our findings weird or useless. One other way that we can do some testing within our experiment is to perform what we call a manipulation check. Let's take another example. If we wanted to make a determination about whether victims in a sexual harassment case got bigger monetary awards if in fact they were more attractive, then a good manipulation check would be to actually have the participants in the study rate the level of attractiveness of the victim in the study itself. This way we know for sure whether the participant actually found the plaintiff attractive or not. So that's basically how we would do a manipulation check. Obviously, that's just an example, and there's lots of different ways that we can do this. Okay, folks, that's it for this series of slides. On to the next.